Mind is a subject that still is not fully defined, and its emergence is not explained. Almost it is unknown. There are different international seminars and conferences subjected consciousness and mind. The members and researchers that present their material in these events are multidisciplinary mostly, and many of them are physicists. String carrier wave is the brain circulating wave that interact with vertical local oscillations over the cortex. String carrier wave has the highest inertia or mass over the parietal, highest moment over the temporal, highest momentum in the limbic system, and highest kinetics over the frontal lobe. What are inertia, momentum, and kinetic, which are applicable to the brain waves? That is a subject we are going to explain here. Inertia is the resistance of a single or coagulated strain package to any change in its transferring velocity when exposed to a stress force. Moment is a measure of the tendency to strain of a connectivity configuration around a specific axis in the location. Momentum is a measurement of a strain package in transfer, reflecting how much inertia a strain package shows in its transfer. Kinetics describe a strain package or coagulated packages transferring in terms of neural assembly position, transferring velocity and acceleration without considering the influence of the stress forces on it, moment and inertia. I know that these terms are defined in very short description and maybe not easy to grasp them. Please Google them or search for more detail because it is beyond the discussion in this presentation. As types of consciousness changes from sensation to perception to feeling and finally to cognition, the property of information current also changes from highly massive, means that with high inertia, to increase in moment, then increase to momentum, and finally increase in kinetics. This variation in information specification supports strain carrier waves around the cortex, starting from the back top of the brain to back bottom of it, and continuing to the front side through the limbic system. The same definition we had for the different aspect of the strain carrier waves, we can have about the information that this strain carrier wave supports. Information mass indicates not connected strain package units. activity. It presents both the memory unit and a conceptual identity. It is like words or nouns in language grammar. Information moment is a chained strain packages. It presents memory units layout. In language grammar, it is like a phrase. Information momentum present dynamics of the chained strain packages. In language grammar, it is like a sentence. Information kinematics shows the strain production rate of the wave. In physics, it presents the combined strain energy production as continuum, and in language grammar, it is like a large piece of information current that convey a more completed meaning, like a paragraph or a full text. Uh, Energy in general is in has an amorph shape. It doesn't have. It is defined that doesn't have any shape in itself. Only a strain energy between all others energy types appear as fragment energy, which is not amorph but decode and carry information by deforming energy units. A strain package is a closed loop of internal strain energy currents along configured connections in a neural assembly that host the related strain package. The significant property of a strain carrier waves around the cortex changes in magnitude from carrying inertia information to moment information, uh, which are in layouts, to momentum information, which are in episodes, and kinematic information, uh, which are in certain formats, the formats that are regulated by procedure modules like memories. All the parameters of information as already described in previous slide are related to mass, momentum and kinetics that in different aspects they define the brain waves around the cortex corresponding to the containing single or coagulated strain packages in different section of the strain carrier wave around the cortex. These parameters include inertia of the floating single strain packages and pieces of the chain, moment of the waving chain, and momentum of the chains, nets, and kinematics of the waving chains nets. In each brain section of parietal, temporal, and prefrontal cortex, one parameter is more significant than others depending on the state of mind. Information inertia is most significant over the parietal, which emerges sensation. Information moment over the temporal, which emerges perception, information, momentum in the limbic system, which segregates regularity of the thought streams, or in other words, theme from irregularity of the streamlines, which is referred as feeling. And finally, the production of the new information that emerge as cognition. As was told, each brain section has its own significant parameter due to over the parietal cortex, strain packages are most segregated, where the medial temporal cortex, strain packages are linked together in chains. Over the hippocampal system, strain chains will segregate from irregular coagulated strain package in chains. Over the prefrontal cortex, strain package waves are locked and structured together. A brain activity is like a plant that grows with roots in the parietal cortex, column in the temporal, branching in the limbic system, and leaves and flowers over the frontal cortex. Neural assembly units with high inertia over the parietal, strain package coagulated layouts with high moments over the temporal, their combinations dynamics in the limbic system with high momentum, and the combination of all over the frontal lobe with high kinetics. These changes indicate differences between consciousness type over related sections. Again, although energy is in general is amorph, strain energy is different, and its streamlines can be regular, semi-regular, or irregular. The difference between mass momentum, and kinetic changes of significant section of the strain carrier waves around the cortex depends on the mentioned characteristic, and based on how much the wave contains loose strain packages or chains of them, or netted floating segments of strain packages, or structured in a short-term or working memory. A strain package is a packet of condensed information encoded by its internal connectivity configuration. By initiation of the strain fragment energy to form, information particle and pieces will join to construct a longer piece of information, to have a longer in length and lasting in time, either as short-term or working memory. The strain carrier wave should have a higher kinetics to provide the chance of coagulation between strain packages. By dropping in kinematics, the coagulated segment will break down in smaller pieces again. The lowest kinematic strain energy wave happens in the deep sleep stages, When strain packages are highly segregated in small species and seed or deform connections configuration in inner cortex layers to encode new memory units. In a higher kinetics condition, which happens in sleep non-REM stage 2, connections start to form uh, uh, in shortest lengths of the strain package linking in fragmental dreaming means that dreaming very short and normally just a scene will appear and it goes. In a further kinetic condition of the REM sleep, structure bonding of the strain packages form longer chain packages with more lasting momentum in shapes of story-like dreams. The most significant example of that is the REM just before waking up early morning, which has got the longest uh, uh, dreaming with very with almost relative relative relevant narrative on it. Longer chains of coagulated strain packages show higher momentum, especially when they are complicated in configuration and larger in size. Those momentum is an indication of the more complicated form of thoughts developed from simpler mentation pieces. In any way, higher strain carrier waves momentum and its higher kinetics are closely connected. In previous slides, comparison of significant physical property in different cortex parts was described. Long-term memory units have a more rigid and stable internal connections. They are positioned in inner cortex layers. Sensory, short-term feeling and working memories, each in their related brain sections, will follow through the outer cortex layers. Inputs to each layer varies from area to area, but mainly the inputs radially enter from the medial cortex fourth layer, where the outputs will dispatch from this sixth layer of the cortex. All these are radial strain changes between the cortex and inner brain. Inner brain includes the limbic system, brainstem, and cerebellum. Strain exchange between the normal assemblies, uh, the words cortex columns, are through the outer layers, especially layers 2 and 3. All the definitions already were given for single and chained as well as netted strain packages and their inertia, momentum and kinetics aspects refer to horizontal strain exchanges between neural assemblies over the cortex. However, neural assemblies reflect a long-term memory property in their inner layers, but current memories sensory, short-term feeling, and working are split between the cortex layers of different cortex sections. Strain package in lower part of a neural assembly is more stagnant and present a long-term memory motif, where the upper part is more flexible in connectivity configuration and able to transfer strain energy horizontally between neural assemblies. In other words, each strain package can be allocated for a potential and a kinetics magnitude in all overall strain energy balance. Strain balance is the state that each brain activity seeks to arrive to that, either in moment scale, means allostatistically, or in periodic scale, homostatistically. Under strain energy current, either strain energy rises from inner layers to outer, means recalling a memory unit, or brainwave imposes strain from outer layers to inner layers, means that to impose and leave strain residuals in the layer for releasing in future. Inertia is defined as a quantitative measurement for a strain package that fits to a neural assembly's connectivity. When that connectivity is tightly tied to the location, it reflects the resistance that the neural assembly shows to change in connectivity configuration, meaning position of the connections against an imposing stress force. Further to the position change resistance, it also resists uh, to uh, keep the position it is, and as well the strain package resists to not be transferred between from one neural assembly to another one in terms of speed and acceleration. Long-term memories with more stable connectivity configuration in inner cortex layers have the highest inertia. They preserve the potential energy of the location. Current memories are more flexible to straining when they are exposed to stress forces because they show less rigidity to temporary deformation over the outer cortex layers whenever exposed to the strain energy stream. Connectivity configuration encode information and current memory follows a pathway that its related components match to the related long-term memory motifs as a stream bit for those current memories. Now we may be able to see the connection between sensation and perceptions to strain exchanges between inner and outer layers in the sensory brain, where they are more vertically. The means that the strain energy will changes in vertical direction because of the higher inertia in the inner layers and least kinematics in inner layers as well, opposite to uh, higher uh, the higher flexibility to conduct and increasing the kinematics to higher amount. Feeling can be allocated to strain exchanges or segregation within segregation between the regularity and irregularity of the current, the means the current short memory, for example, within the limbic system, and it is a mix of vertical and circular strain exchanges uh, which are in conflict with each other. Cognition can be connected to strain exchanges between the inner and outer layers within neural assemblies in the motor brain. It is more horizontally between the cortex layers, between the neural assemblies, and this conduction between neural assemblies is with highest kinematics. So cognition is almost opposite to the sensation and perception, which they are mostly vertical strain exchanges and less in the horizontal directions. Strain carrier waves during brain activity change in physical properties from being rich in inertia to moment to momentum to kinetics content, both horizontal between the cortex sections as well as between its own cortex layers. Strain energy balance around the cortex layers around the cortex may provide a connection between sensation, perception, feeling, and cognition during brain activity. When the brain activity arrives in its termination point, when the strain balance is there. Not during the maturation of each process type, means sensation, perception, cognition, or so on, still the activity dynamically seeks to arrive in its strain balance state, and making a strain balance in that period doesn't give any correct answer to the connection between these different type of the consciousness types. As I told in beginning, mind is a subject that has been discussed along the human history. This presentation tried to explain the different aspects of the mind, its meaning and emergence from a physical point of view, that may open a new front in the study about the mind and consciousness. I'm sorry if the explanations were not clear enough or boring. I hope that all this will be revised and uh, be presented in better quality in future by new version of them. Please do not forget to send your comments and questions to mostatini@gmail.com, and thank you for watching and hearing this presentation.